In here, we're going to talk about one of the properties of sound, and which is the intensity of sound. Okay, or subjectively, I think we should maybe call that the loudness. Okay, and we're going to see the difference between loudness and intensity. Loudness is subjective, and intensity is basically what's physically made. Okay, so everybody hears differently, but the intensity is just one intensity. Okay, so the intensity, I think the definition is given there. So it's objective. Okay, it's what's generated basically. Loudness is what you perceive as loud or not loud, and that's the definition of loudness. Okay, so like older people have a problem hearing, so even if the intensity is high, they don't hear it as a younger person. Okay, the amplitude, and I think we talked about this, is what determines the intensity put into a wave. Okay, so it's the amount of energy put into a wave. It doesn't matter what kind of wave. It could be any wave, is defined by the amplitude of that wave. And this goes back to your first lab in this unit, the very first one, the Slinky lab. Okay. Now, a sound that's twice as loud, so 2 times the loudness, is not 2 times the intensity. So in other words, a sound that has 2 times the intensity it's not perceived as twice as loud. As a matter of fact, if you want to have a sound that's twice as loud, the intensity has to be 10 times as much. Okay, and because of this, the relationship between this subjective idea of loudness and the intensity, we have to use a different scale, because this loudness and intensity are not proportional, right? So we have to use a log base scale, okay, or a decibel scale. Now, the definition of intensity is just power, basically generated by some source divided by the area. Now, these waves are traveling in 3D. These sound waves are traveling in 3D, which means this is kind of like goes back to what we talked about, the gravity. Okay, which means just think of some imaginary spheres around this source of energy here, right? So you're basically the sound is covering the surface of these spheres, and the surface of a sphere is 4 pi r square. So this area here is 4 pi r square, and r is basically how far you are from this source that's generating this sound. And this follows the inverse square law. So in other words, if you go like a meter away from a sound source, you're going to have a certain intensity, right? The power is what's generated by the source. So you're going to have a certain intensity. If you double your distance, the intensity at that point is going to be just a quarter as much. So now you're going to follow the inverse square law, which you should be pretty familiar with. Units, you just have to look at the units for power, and you look at the units for area down here, which is square meters, and power is in watts, so it's watts per square meters. Threshold of hearing is basically the lowest intensity that humans can hear. So if you go below this number, you're not going to be able to hear. This is different than the frequencies that humans can hear. So humans can only hear from 20 to 20,000 hertz, right? Anything outside of that range, no matter how much the intensity is, we're not going to be able to hear it. Okay, so I want to make sure to distinguish between the two. This 10 to the negative 12, even if you are within that range, the 20 to 20,000 hertz, if it's this number or below, you're not going to be able to hear it. Okay? Threshold of pain, and I'll talk about the decibel levels here. It's 1 watt per square meter. So anything at that level or higher is going to be painful to your hearing, and it might cause some damage. Okay, and we'll talk about some real life applications of this stuff. Okay. Now, I said earlier that because 2 times the intensity doesn't produce 2 times the loudness, or is not perceived as 2 times the loudness. It's actually, you need 10 times the intensity for it to be perceived as 2 times the loudness. We have to use a log scale. So I hope you're pretty good with your logs. Okay, because we're going to have to use some of the properties of the logs. Okay, so now the intensity is I. This beta here is the intensity level or the decibel level. Okay, and it follows this formula here. And this I naught is basically this 10 to the negative 1 times 10 to the negative 12. Okay. Now let's look at some, and this is kind of like this picture gives you an idea of the decibel levels, and we can try some of them in class. But look, let's come up with some shortcuts, quick ways of doing things, right? Okay, so let's say your intensity level is multiplied by a factor of 2. What will happen to your decibel level? Okay, so it used to be B old, right? Old. What is the new beta, right? So if I do the formula here, beta is equal to 10 log. My intensity is twice as much. So I just, instead of I put 2I. Then I'm going to do these properties of logs where I'm going to split this into 2. And you know that log of x times y is log of x plus log of y, not times. Okay? If you don't remember this stuff, you should refresh, have a refresher on this, right? So I'm going to leave the 10 here for now, and I'm going to break this into 2. So it's 10 log 2 plus log of I over I naught. Okay? Now if I put the 10 inside, I distribute it, in other words, I should have this. Well, this here is basically just the old beta. In here, if you do this in the calculator, you should get about 3. So which basically means if you double the intensity, your decibel level increases by an additional 3, not a factor of 3. Now what happens if I put n here? We're going to come up with a general form here. Okay, so if I put an n here, this becomes 10 log n. Okay, so this is going to be the old beta, right, plus 10 log the factor that you multiplied your intensity with. Okay, all right. So some of them you have to kind of like know. If I multiply by a factor of 10, let's say, this becomes log. Let me just rewrite this. So I think we say that if we multiply by a factor of n, the new beta should be the old plus 10 log whatever that factor is. Okay? Just remember, when you're dealing with logs, multiplication inside the log becomes an addition of the logs. Okay, so if I make this a 10, this becomes 10 log 10. Now, log, this is log base 10, by the way, of 10 is 1, so this is an additional 10. So you take your old one and you add 10 to it. What happens if this is 100, which is basically 10 square? This becomes 10 log base 10 of 10 square. So I think you can see that this is a 2, because the 2 comes out to the front. This is all properties of log. So this is a 20. So if I do 3 here, this becomes a 3. So it becomes 30. So the rule is this. Each time you multiply your I by 10, by factor of 10, you don't multiply, you add a 10 to your decibel level, to your beta, in other words. Okay? And each time you multiply your I by 2, you add a 3 to the decibel level. Okay? So I'm going to do a quick example, and it should do it with this video. Okay. The sound in Mr. E's class went from 40 decibel to 55 decibel when Sarah Loud started talking to Kevin Noyes. The intensity level increased by a factor of, right? Okay, so I'm going to find the the I for each, add them. You can't just add these two. Okay, so I'm going to find the I for Sarah, and I'm going to find the I for Kevin. So I'm going to say 40 equals 10 log of I over I naught. Okay, so I can divide this by 10, so this becomes a 4. If I try to get rid of the log, so let me see if I can do this quickly here. If I get rid of the log, this becomes 10 to the 4th equals that. Okay, so which means I for Sarah is 10 to the negative 8. Right? Yeah. Watts per square meters. For Kevin, okay, 55 equals 10 log I over 10 to the negative 12. So I can get rid of that, make this 5.5, make this 10 to the 5.5, and multiply. So the I for Kevin should be 10 to the negative 6.5. My calculator. So this is 3.16, 10 to the negative 7 watts per square meters. Now you find the total I, okay, which is the sum of those two, and that should give you 3.26 e to the negative 7 watts per square meters. Now to find the overall beta, you do 10 log of this value over 10 to the negative 12. Now let's see what that gives us. So I'm getting 55.135 decibels, right? So it doesn't change it much. So it will change it a lot if they are really, really close. So in other words, what this means, it means that this 55 decibels is a lot greater than the 40 decibels, which means it dominates. And you can probably see that in here, right? So this one here is greater than the one on the for Sarah, right? This should do it. Have a great day.